Right, welcome. So here we're at 7.4. We're bringing everything together. So we've learned, let me go to some of these. So we started with just simplifying, where are we? Simplifying exponents. So here we learned about, what the base is, what an exponent is, what a coefficient is. Then we learned that we can simplify things by expanding expressions. Okay, we learned the zero property. Anything to zero is 1. And we also learned about negative exponents. So the first thing we always want to do is take care of any negative exponents by doing its reciprocal and changing the sign of that exponent. Okay, so that's a quick review of that first lesson. And we also learned about multiplying expressions that have exponents. What we learned is that, this is kind of the key, is right here. That if we have two bases that are the same and we're multiplying them, then we add their exponents. Right? And we did a lot of examples of that. And then our next lesson we talked about when we divide expressions with exponents. And the key for that was if you were dividing, I wrote it right here. This would be the key thing, is when we are dividing expressions that have the same base and we're dividing them, we subtract their exponents. Right? So we covered all of that information. Now we're going to bring it all together. Okay? So a lot of these, when we have, let me just read this. It says the division bar, so like right here where I color that red, that is a division bar. Okay, it's a grouping symbol, which means that we have to follow order of operations. We first want to simplify the numerator and then the denominator, and then we'll combine like terms. Okay, so for example, let's just start with this expression for number 1. Okay, in this situation, the parentheses aren't necessary. You could just ignore those. Okay, and we want to evaluate what's on the top. Okay, so the numerator, remember, since we're multiplying them, we add their exponents. So that would be x to the 2 minus 4, or you could say plus a negative 4, if that helps. And then on the bottom we have x to the 3 plus 4. So that gives us x to the negative 2 over x to the positive 7. Okay? And then we always want to take care of any negative exponents. So since this is a negative exponent, we want to bring it down to the bottom. So that would be 1 over x to the 7th, x squared. Okay? And then since they're multiplying, we'll add those exponents. So that would give us 1 over x to the 9th. Okay? And since everything is either being multiplied or divided, it really doesn't matter what order you do things, as long as you do it correctly. Okay? All right, let's do another example. Right? We could simplify everything that's on the top, and then we could simplify everything that's on the bottom. Okay? So that would give us, these are being multiplied. They have the same bases, so we'll add those exponents. So that'd be a to the 6 plus a negative 2. And then we have b to the 10. On the bottom we have a to the 3rd and b to the 7th. So that gives us a to the 4th, b to the 10th, over a to the 3rd times b to the 7th. Okay? And then we know if we're dividing, then we subtract their exponents. So that would be the same as a to the 4 minus 3, because they have the same base. And then we'd have b to the 10 minus 7. Okay? And that ends up giving us a to the 1, which is just a, and then b to the 3rd. Okay? Do another example. Okay? We're multiplying right here between those two. But when we multiply straight across. So it's as if there isn't a multiply sign, okay? So again, we want to do everything perhaps that's on the top. So we have 3 times 2, and then we have y to the negative 2, and we have plus 10, okay? So same bases, so we add their exponents. And then we also have an x squared. On the denominator, we have 7y, and we could say this is y to the 1, this would be y to the 1, so it would be 1 plus 1. Okay? Or you could just think of it as y times y, well, that's just y squared. Okay? So then we just combine everything we can. So 2 times 3. 3 is 6. Y, negative 2 plus 10, that gives us y to the 8th, x squared, all over 7y squared. Okay? And then we're just going to, since these are the like bases and they're being divided, so we subtract their exponents. So we do 6, I guess we could rewrite it here, 6y to the 8th minus 2, and then we'd have x squared all over 7. So we get 6 times y to the 6th, x squared all over 7 would be your final simplified answer. Okay? All right, and if you wanted to expand these things instead, there's nothing wrong with doing that too. Okay, so, but just make sure that we always take care of the negative exponents first. All right? So, all right, so here, let's do another one, okay? So we have our constants, we could bring those out. So 4 times 2, we have a to the negative 2, and then we have another a to the negative 2, so we would add another negative 2, and then we'd have 2 over a to the negative 4. Simplify that, that gives us 8 over, or 8, and this would be a to the negative 4, and this would be 2 times a to the negative 4. All right, well, these are the same, top and bottom, those cancel. And 8 divided by 4, or 2, sorry, is 4. Okay, so our answer for this one would just be 4. Okay, here's another example. Again, since these are just being multiplied to each other, I mean, you can also ignore those parentheses as well, okay? All right, and then we can do the same thing we did before. So just combine, or let's do all of the x's on the top. So that would give us x squared, and then we have a minus 3. And we have a y to the negative 4, and a plus 5, all over x to the 3 plus 1, so here are 3 and r1. And then we do y to the 4 plus a negative, plus a negative 2. Okay, so that gives us x to the negative 1, y to the positive 1, and then on the bottom we have x to the 4th and y squared. Okay, and then again, we have negative exponents, we should bring that down. Okay, or if you, I mean, like I said, there's lots of different ways to do this, so as long as you feel comfortable doing it the way you like to do it, then that's fine. Okay, so that gives us well, let's do it using division. So we'd do x to the negative 1 minus 4, and here we'd get y to the 1 minus 2. Okay, that ends up giving us x to the negative 5, y to the negative 1, and then we need to take care of those negative exponents. So we'd want to bring them down to the bottom, and we'd get 1 over x to the positive 5th and y to the 1. Okay, so you may want to look at that, be a little more, make sure you understand how this all turned out. There's lots, like again, there's lots of different orders to do this. And it just depends on what works best for you. Okay, this is another problem that we kind of already did. Area, we know that area is length times width. You could say that this would be length, this could be your width. And we just want to find the area, so we'll just multiply them. A squared times a to the fourth times b to the third. Okay, and then we just need to simplify. Since these are being multiplied, the a's are being multiplied, we're going to add those exponents. So a to the sixth, b to the third. Okay, here is a square, meaning that all sides are the same. So if we want to find the area, it's going to be length times width, which is also a to the third times b. Okay, so we're just going to multiply them to each other. So a to the third times b, and then we're going to multiply that by a to the third times b. Okay, they're all being multiplied, so we'll add their exponents. So a to the sixth times b squared. The last question is how much bigger is the volume of a rectangular than a square? Okay. Oh, we're talking about these two problems, sorry. So gotcha. So we want to find basically the ratio of the areas, okay? So we want to do something like a to the sixth, b to the third from here, and see how many times this smaller triangle can go into it, okay? So we divide that by a to the third, b. Okay, and then we just want to simplify. That would be a to the sixth minus 3, and b to the third minus 1. Oops, sorry, I wrote this down wrong. This is 6. My bad. Sorry, okay, so we're looking at these two. So that would be a to the sixth, b to the third, divided by a to the sixth over b squared. Okay? So you end up getting b times bigger. Okay? If you have any questions, let me know. Oh, over here we have an activity. We may or may not do this in class, so just so you know. Okay? All right, see ya.